Hello, welcome to this video in which I want to introduce SimSig as a signalling box simulation based on the United Kingdom. And simsig.co.uk has several of these, quite a few in fact, that are downloadable. Some of them are free, some of them are donationware, which means you can kind of make a donation, a bit like shareware, pay some money if you enjoy it. And others you have to pay for to download. They're usually the largest simulations and cover a larger area. But what I want to do is look at the basics of using SimSig, how a signaller is going to interact with the control system. And just for your information, this is actually based on real UK practice. So the screens that you see on these simulations are pretty much exactly what a signaller would see. So in this case we have Royston. Royston station is down here, and this is the smallest of the simulations, I think possibly apart from the Waterloo and City line. And as you can see, it only consists of one screen. So you see down here, sorry my taskbar's in the way. See down here you have this view one. So on some of the older simulations, these are split into screens. You might have 1, 2, 3, 4, 5, 6, 7, etc. Which in real life would be what would happen. Sorry, let me just answer the phone. What would happen in a signaling control center is that you would have multiple screens, multiple monitors, and each one of these views would be on its own monitor. And then usually on the larger simulations you will have probably 3, 4, 5 people who are operating different parts of the layout. So what you can do with SimSig is you can network these together. So on the more complex simulation you could set them up on a local area network or even across the internet, and you could have 5 people in different places all operating different panels of the same simulation, seeing the same trains, coordinating with each other and everything else. So on the newer simulations you tend to find that instead of these views you will have a single scrollable window. So you'll have a scroll bar across the bottom and you'll have one up the side as well, and you'll be able to scroll across the simulation from one end to the other. And you can see that on my other video for Birmingham New Street, and lots of the others. Exeter does that as well, and the Scotland ones do that as well. So you can do that on the larger simulations. The other thing is that you are able to chain some of these simulations together. So I'm not sure if there is a simulation for Cambridge, but if there was, you would be able to connect this simulation to somebody else running the Cambridge one. So if they sent you trains, you would see them arrive here, and when you send trains out they appear on the other person's simulation, just as a way of linking them together. And so with all of the different simulations that are available, you can cover really quite a great area of the UK and have a very real life simulation going on. So what we have running in here and running in all the other simulations is we have a timetable. So these timetables are included. There's usually at least one included with the simulation. You can create your own timetables if you want, if you're into that kind of thing. And on the timetable list you'll see there's different tabs, because obviously the timetable can have lots of complex information underneath it. But the basic gist of it is each simulation will have certain types of train. So in the case of this line, which is the King's Cross to Cambridge line, you tend to have a 313 as a local electric multiple unit, and the 317s and 365s tend to be slightly faster, kind of 100-mile-an-hour multiple units, and they have a generic freight train. On some of the other simulations you could have a lot more different train types, but for this one they're all the types we have. And then what happens is somebody sat down and worked out a timetable. This is probably a real timetable, and if you click on a particular entry and edit it, you'll see the sorts of information that is here. So this says this train always runs, so it runs 100% of the time. So you could have specials that run 50% of the time or whatever. You then have where it's going to come in. So the entry point to the simulation in this case is Baldock, which is up here, the entry time and the head code or the ID of the train. and then you got the characteristics, so you choose what type of train it is, a 313. It takes overhead power. All of these things are important on some simulations where you might have an unpowered line, and if you have an unpowered line, then if you try and send this train, which is electric, onto a diesel line, then the train will stop and tell you that it can't go there. So you've got various physical things like the length of the train and the maximum speed as well, and also the acceleration. So all of these trying to mimic as realistically as possible the different types of trains that you'll see on the simulation. And then in this case, this is a very simple train. It enters at 3:27, which hopefully will happen fairly soon, at Baldock, which is at the west end of this line. And in this case, it has one stopping point, which is platform 1 at Royston. And the other thing it says, which is important, which we'll see soon, is what happens next. So once that train 5R96 arrives at Royston, it becomes 2R96. Now a class 5 train is an empty coaching stock, so that's obviously come from a depot somewhere or from wherever it finished last night, and it's coming into here, and because it becomes a class 2, that means it becomes effectively a stopping service. But nowadays the idea of class 1 and class 2 trains is not really quite so clearly defined, but in general class 1 train is for expresses, a class 2 is for a stopping service of some sort, a class 3 is usually a faster freight train, like a network rail inspection train or something like that. Class 4 is a faster freight train, so usually anything from 75 to 100 mile an hour freight train. Then class 5 is for empty coaching stock. Class 6 is a 60 mile an hour freight train, and class 7 is a 45 mile an hour freight train. And then classes 8 and 9 are usually specials, such as track machines and things like that, that usually run very slowly. So in general, class 1 is the fastest and highest priority, right down to class 9, which is the slowest. The other addition to that is a class 0 train is a locomotive only, what we'd call a light locomotive working, and 0 being kind of the lowest priority really, so it's more like 10 than 0. And light locos don't usually have a timetabled set of stops. They tend to run as required, and it's up to the signaller to make sure that they get through okay, as easily as possible. So as you might imagine, being a signaller is primarily about making the trains run to time and making them run safely. Now, in the old days, the very, very early days, it would be quite easy for a signaller to run two trains into each other. However, with block signalling, as we have here, and having the track separated up into blocks with each protected by signal, that becomes much harder. And also, as time went by, people started to do things like interlocking. So what interlocking means is, if I set this route, so I click on the entry signal, we call this NX for entry exit, click on the entry signal and the exit signal, and what you'll see is it set the points across there, and the bar has gone white. So what that means is that a route has been set across those points. So for instance, if this train was coming in and needed to go onto platform 2, obviously we could do this. And what this means in terms of interlocking is, if I now try and click this signal and I try and cross here, that's not going to work. And the reason it's not going to work is because the points are interlocked, and it effectively says the points need to be this way round for this route to be signaled. Now if the points are this way round, I can't turn the points the other way around to set a different route, otherwise there would be a conflict. So interlocking mostly stops you from doing dangerous things. You notice a message came up saying that the points are locked normal. Normal means in a certain direction, in this case straight through, by another route. So if I wanted to set that, I'd have to cancel this route or wait for the train to cross it, so that after the train crosses, the route releases automatically and I can set another route across here. The other thing is that the first train has arrived on here, so you'll see the red block is where the track circuits detect the train to be. That normally works okay, except sometimes you will get an error, a failure, and you'll get a message saying that a track circuit error has been detected, and what happens then is usually you'll see a bit of red will block the line, let's say here, even though the train's moving. And when that happens, that will cause the signal to go to red because the system thinks there's a train, which then means every single train is going to stop at the signal. They're going to call you eventually on the phone and tell you that they're waiting at red signal, and you would then have to tell them to examine the line and pass the signal at danger. Now, one of the things that's really nice about these new electronic control centers is I can click on this and that will tell me the platform 1 at Royston. So platform 1 is actually down here. Be careful on this simulation because even though it's simple, there are a lot of platform swapping. So you sometimes get trains reversing into platform 1. You sometimes get trains going into platform 2 and then they can reverse back out. And likewise, trains coming in from platform into platform 1 or 2 from the Cambridge end. The other thing that happens sometimes is a train will stop, let's say platform 2, and a faster train will go past it in platform 1 or the other way around. So in Royston, you need to keep checking these platforms. Now I'm coming across here, I'm coming across Litlington level crossing, and I need to come across Ivy Farm. So I'm going to set that signal here. Now an automatic button, which I'm going to click, means that it's going to keep this route locked for straight on. And the reason I want to do that is because there's not a lot of freight coming into here. So if that goes off automatic, then that signal will go back to red every single time, which means for every train I need to then set the route again. So by putting that on auto, that route will stay set. If a freight train does come, I need to make sure I cancel that route in plenty of time so that I can then set the signal into the loop. Or if I need to allow a train out of here, I will also need to cancel it. But what I've done, again, entry exit, I've clicked from the entry signal into the exit signal. If I want to do more than one, I can, but I have to do them one at a time. So I do that to that, that to that, that to that, etc. In this case, the train's reversing at Royston. I don't necessarily know that. I'm guessing that because it's gone into platform 1, it is reversing. But what happens here is 2R96. I can right click that and click this interpose, and I can change this to be 2R96. And what happens now, although I took too long to do that, so I'm going to do it again, 2R96. So now if I click on that, it will tell me that at 3:39 this train's going to leave and it's going to go back to Baldock, which is up there. So it is reversing. If I end up with a number like that, I can right click and hit cancel. That doesn't cancel the train, it just cancels the code, so don't worry about it. And even if you cancel that by accident, what you can also do is press the letter I for interposed by a signal, and I can type in 2R96 and I can click on a signal, and that will put the code in next to the signal for me. So I can do it that way as well. But that will click in there, and what will happen is one of a number of things. Depending on the station that you're at, there might well be a train ready to start button, and that's what the platform staff press to tell the signal box the train's nearly ready to go, and it's a way of flagging the signalman to set the signal here for that train. Now the reason that's useful, certainly at the busier stations, is you can have lots and lots of trains and any of them can become delayed. You can have a wheelchair user trying to get on or off. You can have something happening on the train or the police being called. If you start setting routes when the train's not ready, then give it 1 or 2 minutes and another train wants to leave, and you're going to end up with a blocked route. If you cancel a route when this train has any signal other than red, so if that's next to a yellow, a double yellow or a green, and you cancel that route down, then you will get a performance penalty, and you will usually get a time delay before the route will release. And that's for safety reasons. If a train's coming up here at 100 miles an hour and you suddenly decide to cancel the route in front of it, well, that train's going to have to take some time to stop. So the system counts down up to 2 minutes, so just to make sure that that train has managed to stop before the signal that you've cancelled. So if you set routes too soon and you have to cancel them, you can end up taking a long time, and very quickly the trains will get delayed. So I don't actually know if Royston has a train ready to start button. If it doesn't, then what will happen? Oh, it does. Okay, so what happens is a message comes up here saying train ready to start for 2R96. A little white thing is flashing here, so I can set that route, and then as soon as that's green, the train's ready to leave, the platform staff will blow the whistle and that can go. Now it usually happens reasonably quickly, the train ready to start, so it's useful to know what's going to happen next, just so you're ready to set that route. And it also means you've got to be a bit careful about other train movements. So let's imagine you had a freight train coming up here, and you might think, oh, let's pop him round into platform 2, let's go along, let's go back down, and let's go past the class 2 train. Well, if you do that and you set the route, and then as the freight train gets to here, you suddenly get the train ready to start button, then this train is now going to have to wait for that freight train to clear all the way up here, enough signals to then get a chance to start. And depending on if it's not stopping at Ashwell and Morden, then this ends up getting delayed because it's stuck behind a freight train. So you've just got to be a bit careful about knowing which trains are due to leave when. So that's your kind of your first train. We brought it in, we brought it across 2 level crossings into platform 1, and we've now sent it back again with the new head code. Now in this case, all of the grey signals are automatic, that's why they don't show a colour, and that means at this point I've got nothing left to do for that train. Unless something breaks down on the way, I can forget about that and wait for my next train, which, if I look at my timetable, the grey ones are ones that have already been and gone. So the next one says that at 4:30 another empty coach in stock train is going to arrive. Now it's obviously a long time till 4:30, so what I can do is I can press F3 and that brings up the options, and there's lots of different options, the noises to play when things happen, all those kinds of stuff. But on general, we can also speed things up. So if I drag that all the way to the end and click OK, you'll notice that that train starts moving very, very quickly. The clock starts counting much more quickly, so I can kind of speed things up that way. I'm just going to drag it down a bit for the time being. So let's look at a couple of other features of SimSig. So this doesn't have every different thing that exists on every simulation. Because this mirrors real life, you'll find that some of the other simulations will have different signaling practices. They might have connections to other signal boxes that require you to press certain buttons when you're sending or receiving a train. You might have, sometimes when you have sidings like this, what will happen is usually you'll get a telephone call and you'll answer it, and it will be a shunter telling you that a train is ready at the siding, and I think that's what happens here. In some simulations, in order to send a train into the siding, you first have to call them by placing a call. In this case you can't do it, there's no one to call. Another one, you might have to call and you might have to say, I have train, 6C52 ready for you to receive, and the shunter might say I'm not ready for it, or they might say please send it through to siding number 6 or whatever. So there's kind of lots of random different bits, but I guess the main things at this stage are that you have the circular signals are the main signals. That's what you would see mostly next to the track, and then these little triangle signals that you see underneath are what we call shunt signals. They will usually be down on the track next to points. Usually you'll see some next to the points there. Sometimes they are attached to the same post as the main signal, and what shunt signals enable you to do is it mostly enables you to do movements into sidings or special movements for freight trains. So it depends on whether the route is a main route. So if I click from here to, no, that's not that one, let's go from that one to that one, you'll see that it's the main signal that gets lit up, and that's because that's a main signaled route that is used in normal operation. However, if I want to go from, let's say, here to here, that because it's coming out of a siding that isn't a main signaled route, it doesn't have a main signal, even though it could, but it doesn't because it's not a main route. You notice there's a shunt signal instead, and that means usually that the train has to proceed slowly, usually no more than walking speed, 5 miles an hour, until it gets to a main signal, which might look like, let's say, like this. And as soon as that train gets to the main signal, it can then speed up to line speed. So shunt moves are normally made at low speed, and you notice here I've cancelled it, and again it's given me this approach locking, 30 seconds approach locking, and that is because it doesn't know if a train's actually coming, because this empty track means that there isn't a track circuit detection, so it can't see whether there's a train in there or not. So it's given me 30 seconds of locking before it's cleared that route down. Same with all of these, move, from signals from one place to another. Now another thing to note is you can't go from anywhere to anywhere. So if I want to go, say, from here to platform 2, I can't. If I try it, I can actually. It will let me go from there right up to the signal, so that does work. But if that's now going to give me 30 seconds approach locking. But there are certain routes that it won't let me do, and that's just because they're not needed for the timetable. They're not designed to be used, and that might be because I have to go via another shunt signal and out. It might just be because I can't do it. There are just some routes that I can't do. So for instance, I can't come from here up this track into the loop. Actually, sorry, I can. I just saw that signal there. So I can do that. That's fine. If I cancel this one down, I shouldn't have any approach locking because the system knows that there isn't a train there, so that will close that down. But you can't always go everywhere. So when you learn a simulation, one of the first things that you start doing is you start learning what you can and can't do. And especially on some of the more complicated simulations, you'll have to also try and work out which path to take into a station. So you might have a station throat with maybe 4, 5, 6 entry roads, and usually when you click the number on the train when it arrives, it will tell you whether it's going in via the down loop or the main or the relief or whatever the lines are called. But once we do this, you've probably kind of got enough information now to make the most of this situation. Two other things I want to cover quickly are level crossings and failures. So these level crossings here, this one happens to be, or both of them actually happen to be, automatic half barrier level crossings. And what that means is, as the signalman, you don't have to operate these. They will operate themselves. When a train approaches, the barrier will go down, that working light will flash, and then when the train's gone past, it will raise again and it will show as raised. This one isn't actually a half barrier, it's a telephone crossing, which means it's not protected. And what's supposed to happen, because it's a farm crossing, is, let's say there's a flock of sheep that need to cross the track. You will get a telephone call, the telephone icon here will flash, you will answer it, and you saw that right at the start of the simulation, and somebody will say, I've got a slow vehicle crossing, I've got a flock of sheep, I've got whatever it is crossing, and they're asking you as the signalman whether it's safe to cross. How do you decide? Well, quite simply, you have to decide, is there a train that's going to be here in the next, let's say, 5 minutes? Now, let's supposing they called up here now from Linton and asked if they could cross. You would say, right, no trains coming here, no trains coming from Cambridge, so I'm going to say yes, it is safe to cross. But the other thing I'm going to do is I'm going to pop the emergency stop on that signal, and that just protects this crossing. I can do the same on the other side, protects the crossing while that person is going over. Now ideally they will call you a few minutes afterwards and tell you that the crossing's clear again, in which case I left click the emergency stop and they go back to normal. That's fine. Obviously in real life they might not call you back because they might forget, or the telephone's broken or something, in which case you are going to have to assume as a signalman that the crossing is still blocked. And what that means is eventually a train's going to come in here, they're going to stop at the signal, they're probably going to call you up and say, I'm waiting at a red signal, and you're going to have to say to them to pass the signal at danger and examine the line, because what you're basically saying is, it's been 10-15 minutes, I don't know what's going on. And what the train will then do is it'll go past at 5 miles an hour, it'll keep an eye out for stuff. If there is somebody still on the level crossing, the train will stop, but it will go slowly, and then the train will stop at the next signal and they will call you back again and say the line's clear, it's no problem, in which case you could pop the things and open up the crossing again. Sometimes these crossings in real life have cameras, and the signalman can actually see whether the person's crossed or not. Usually if that's the case, instead of telephone it will say CCTV, and sometimes the signalman has to cross it. So that's kind of what you do level crossings. If you play things like the Cambridge simulation, there is a Cambridge one actually because I have seen it, there are loads and loads of level crossings, so you get phone calls all the time, and it's really difficult because you've got to know where all of the level crossings are so you can then see whether it's safe to cross. And of course sometimes it isn't safe to cross, in which case you'll have to say to them, please call me back in 5 or 10 minutes and ask again. So that's what you do with those. The other thing that happens sometimes, even on the simple modes, is you'll get a failure happen, and you might get a signal failure. So one of these might just suddenly go red for no reason. Most often you will either get a points failure, so you see when you change the points, they flash while they change. If there's a points failure, it carries on flashing and you will get a message saying that there's a points failure. Now what that means is you always know where the points are set, although usually what it means is they're set in one position and not in the other. So if that starts flashing, what you can try is well, if I set that and it stops flashing, then maybe that direction works okay, but if I try this and it just keeps flashing, it means the points can't reverse. So you can sometimes work out which way the points are stuck. If that happens, all you can do is try and work out how to regulate the trains. So let's say that, I don't know, let's think of an example. So if, say, these points down here were broken, you might basically have to put all of the trains through platform 2, even if they're scheduled to come through platform 1. So trains from London would go through platform 2 straight ahead as normal, but trains from Cambridge would have to cross over here to avoid the broken points into platform 2 and then go back over, and that's going to cause delays at some times of the day. There's no way to avoid that, but your job as a signalman is to regulate those and to keep the delays down to a minimum. You will lose points anyway if you delay trains. There's nothing you can do about that. F5 shows you your performance, so at the minute I've obviously not lost any time, I haven't done anything wrong. But if those failures happen, that will happen eventually. An engineer will call you on the phone, you'll get a phone, you'll answer the call, it'll be the engineer and he'll basically tell you I fixed it and you're all back to normal. The other thing that happens, very similar kind of problems, you'll get a track circuit defect and you'll get a red bar somewhere where effectively the system thinks the train is still there, it doesn't know what to do. The signals will respond as if the train is there. Usually you'll know that it's a track circuit failure. You will then have to tell every single train after it stops that it can pass the first one. You should tell them to examine the line, and after that you should just tell them to pass the signal at danger. They'll go through slowly till they reach the next signal, they'll speed up again. It will slow you down, it will be a pain, but there's not really anything you can do because that is real life. So have a go at this. You can speed it up, like I say, depending on how kind of confident you are. You speed up fairly quickly. When it gets to kind of the busiest times of the day, which is the morning and afternoon rush hour, you have some kind of platform regulation to do. But other than that, it's a fairly straightforward simulation, and this will enable you to cut your teeth to then look at some of the slightly bigger simulations. Don't go too big at once. And as you start to go bigger, make sure you read the help notes for each simulation, because some of them have funny things, like they might have a hidden ground frame for certain points, and in order to get the train in or out you have to do funny things with the levers. Usually there'll be a menu item for it, so one of these menus will have the ground frames on, but again you're only going to know that if you read the help or play the simulation, and as soon as you get a message coming up saying somebody's trying to enter from, you know, such and such a siding, press P to pause it. It shows pause down here. On the newer ones, these windows all float and you'll have a separate window. The clock gets crossed out with a red line. Pause it, read the help notes and say, how do I get a train into or out of that siding? But otherwise, hopefully you can enjoy that. There should be enough information there, I hope, for you to work out how to get on with SimSig and then get you addicted so you start downloading some more simulations. So just as a disclaimer, I don't work for SimSig and I have no connection with them, but I do enjoy their simulations and I hope you will too.